Measure twice, cut once.
Yeah.
I'd like you all to put your hand on the scissors.
When we do it, Badri, hang tight. I gotta say a few things, okay? Let me say a few things. So, distinguished visitors and guests, I want to welcome you to this special event today. We're here basically to commemorate our outdoor museum. So it's our special ribbon cutting. I mean, like everything, it starts with an idea or a dream, and this activity, outdoor museum, is no different. It started with a dream about 8 years ago from Massey, who at the time was our outreach coordinator. Said, hey, wouldn't it be great to have an outdoor museum for visitors and guests to see some of the componentry that are on some of our antenna systems? Unfortunately, we could never really find all the money necessary to put it together, or all the parts for that matter. So it was conceived over 8 years ago. It was made possible by the funding of NASA and the Jet Propulsion Laboratory. It was built by Dianna Corporation and some of our Goldstone personnel. We're here today to commemorate and to celebrate this ribbon cutting. Present today is myself. My name is Sonny Giroux. I am the DSN OM Contract Program Manager. And our ribbon cutting will be done by Badri Younes, the NASA Deputy Associate Administrator for the Space Communications and Network. We have Bhanji, who is the JPL Deep Space Network Project Manager. Peter Vrotsos, the NASA Scan Network Services Manager. Wayne Sible, our JPL DSN Deputy Project Manager. Barbara Adde, the NASA Policy and Communications Director for SCAN. Shannon McConnell, the JPL DSN Outreach Coordinator. And by the way, it was those two who was able to get us the money to make this happen.
Yeah.
Dianna Ross, our Barstow Chamber of Commerce Executive Director. So without, and Michael Clements, excuse me, my other compatriot and holding the ribbon, is the Goldstone Complex Manager. So without further ado,
Okay, Barbara and Wayne also each. Okay, ready?
Yeah.
I do have a little parrot in my car. I will hear about this.
But we put this area right here together very special because most of you will never ever get an opportunity to be in the dish of one of these antennas. And this particular Deep Space Station 12 antenna has a cone, a Cassegrain cone, just like this cone here. It's for S and X band. We have a subreflector identical to the one that is up in this dish, and we have a dichroic plate just the same that we would have in a dish like the Echo antenna. And so this helps us on the ground to tell the story of how we actually receive a spacecraft signal. So I want you to kind of keep that in mind as you walk around. We would actually take a dichroic plate and put it over one of the feed horns that we want to pass the signal through. We always receive multiple signals from our spacecraft, and I'll just for general purposes use S and X band. So this dichroic plate here was machined to allow an X-band signal to pass through the holes at the same time as reflecting the S-band signal. We use a solid plate when the S-band signal then is reflected and focused into an S-band feed horn. So the gold feed horn up there is an S-band feed horn. The smaller feed horn is X-band. So by using this equipment, we are able to receive multiple frequencies, focus to a subreflector, refocus down into the feed horn using a dichroic plate to split the signals to the appropriate pathway. So as you go through here and you read this, you'll see diagrams. So if I just confused you with everything I said, it will help make sense. Okay?
Great.
So follow the serpentine path and enjoy being the first visitors to this open air museum. When you travel to take a look at our site today, you're going to be on a bus traveling. When we get to Apollo Valley, the other two sites would actually fit in Apollo Valley, geographic wise. And why? Well, we were the first, and in the early days they thought what transmitted from one antenna could interfere with the reception of another, so we were spread out into specific bowl-shaped areas to make sure we didn't interfere. But as we got older and wiser, we realized they didn't. So on the other two facilities, they were able to co-locate all of the antennas.
And the one in Madrid, is that how I understand why this is so far from like a city, but
Right.
it's the one in Madrid that seems like...
It's not actually in Madrid. It's in
close.
a small town called Vrotsos. It's outside of there. We all went far out. So, you know, you have to think about the way the world was in the late 50s, early 60s, and all the transmission through the air for TV, for radio. So we went for an area where there was no noise. And so that's why we ended up where we are. I do recommend, if you get to Australia, to visit the Canberra site. If you get to Madrid, visit the site. They both have really nice visitor centers and great people that are more than happy to talk to you about what goes on in the Deep Space Network.
So everything comes through here, space station and the Mars?
We do not do the space station. We do not do human exploration here right now. We do everything deep space, which is defined as past the moon. So yes, if it's on Mars, it comes through here. All of the Voyager spacecraft, all of the ones since 1958 have come through here. We've been busy. Yeah. Goldstone is one corner of 3 complexes that make up the Deep Space Network. We use it for Operation 6. We have a research and development antenna so that if it's going to be used in the Deep Space Network, it's tested, designed, implemented
So you got
there
6
first.
plus 1 research?
Yes.
And so they vary from size of 34 meters?
They're either 34 meters or the 170 meter. We started out with 26 meter antennas, but really it just wasn't big enough at the 26 meter size. Once we made the change, in the early days we were just S-band, you know, and 26 meter seemed to work out. But as we went farther for the Voyagers, this antenna right here started out as 26 meter. It was upgraded in 1978 to become a 34 meter, and we added the downlink capability of X-band. And so then as we evolved, now we have the uplink capability at X-band, so up and down X, and we still have the older spacecraft that still have the S-band, and now we're working up into the KA range. So, you know, it's ever evolving. The higher the frequency, more data on the downlink, so it's very attractive.
The Mars stuff would generally go through the big dish?
Not always, no. No, our 34 meters are perfectly capable of bringing the data back from Mars.
Exactly.
So it's all good. It's all good.
But it's two-way, right? Bringing it back? And
Yeah, absolutely. We provide the transmitted signal to the spacecraft. It's transponded, turned around, so we have the carrier for the data to ride down on. And so we provide that uplink, so we get all the commands going up, and commands can actually scoop that soil. If it's on the rover, it can be hang a left at Jupiter. Something, you know, if it's a spacecraft still on its way. So, you know, it could be the general health of the spacecraft, wanting to know how well the batteries are and what's the temperature inside the spacecraft. So all kinds of.
What can Voyager still do? Because that was pretty basic.
Well, no, at the time it was cutting edge.
Yeah.
Yeah, but we're still trying to determine, are we through the helio sheath yet?
You've got segments meeting and you've got any...
But that's all part of my talk. I don't want to ruin that.
You can do a lot. You know, there are many explorers that went and discovered great things, but nobody heard about them. They died. our plan is really to make sure that everything we do, everything we accomplish, everything that we do, to benefit the taxpayers and humanity at large, gets communicated. The value of the information is how do you use it, how do you communicate it, how do you disseminate it. So we definitely have a great website. We have been for quite some time engaged in trying to get the message out. We have been involved with a lot of organizations, and this is now an opportunity for us to engage with you, to become partner and moving forward.
What would you say to a 10-year-old about getting involved in NASA?
Oh, NASA provides great opportunities. It gives you the kind of satisfaction in in building and trying to realize your dreams. NASA probably is one of the organizations that can allow many of us to pursue our dreams and really work on them and see them come to reality. So it's NASA is a dream realizer and provides the kind of activities and work that really pushes the envelope of technology and science. And listen, exploration is in our blood. We are all explorers. We are born with it. It's so ingrained in our DNA. We all want to know why and how and where to and where from. NASA provides you the opportunity to wonder about all of these things and pursue the kind of initiatives that can get you there, get you some answers. So NASA is the most wonderful place for those dreamers, those people with great imagination. And if you have that great imagination, you have that dream, come to us. We are waiting for you.
Your passion is so evident. Thank you.
No, but, it started with the Apollo days, when we landed on the moon. That's when I looked up there, I said, I'm going to be there. I'm going to work for NASA. I'm going to get somewhere. If I don't get somewhere, I can help others. I can help humanity discover more about its origin and where we are going as a species. What's going to happen to this globe? What's going to happen to life? How can we do it better? And throughout our work, also, we produce the kind of technology that helped the ordinary folks. Every product that you use, from this camera to that camera to the chip that the microchip that have been used in there, something that NASA worked on, and introduced to transfer to the commercial sector. So there is a great benefit for everything that we do. It's not just the human space flight aspect or the exploration of distant planet. That definitely that appeals to our dreams, helps us. But the technology that we generate and gets transferred, into our economy, that has helped us as a country to move forward, to advance, and hopefully we'll continue on this path.
David McBride from NASA Dryden says it's not what happens in space, it's what we do, the experiments we come back to.
Ultimately, the taxpayer, the human, side of, our adventure is what at the heart of our interest. Anything we do, definitely, we are curious. We would like to discover new things. We'd like to get answers to our question. But ultimately, we do it, on behalf of the taxpayers, for the benefit of the taxpayer.
What you hear more and more too, as the exploration becomes more intense, is the possibility of life, on someplace else other than Earth. As they discover, water and possibilities out there. So when you talk about children and having that excitement and that passion, you can tell them, you can look up at the moon, and a 10-year-old, you can say, you may be there. One of you could possibly be there at some point. So I think in terms of that excitement when the first man landed on the moon, and then to some degree that kind of ebbed away. Now I feel like that excitement is coming back, in a much more, passionate way.
Yeah, I'm hoping, in partnership with you, with your help, we can also continue trying to stimulate the mind and sensitize the young folks and generate that interest in space. Definitely, I'm hoping the one watching this will become the next astronaut, probably become the next one who discovers a cure to a lot of diseases, probably the one who will discover how we can go faster than the speed of light, challenges the existing laws of physics, get us to a new physics that will allow us, you know, to become in charge, not in charge and in control of our own planet, but you know, of our universe. The universe offers a lot of opportunities. It's waiting for you to discover them.
Right, and I'm the principal at Tiford, which is right over here on the base. So the fact that those students are sitting there and they are on their computers controlling these dishes and receiving signals from millions and millions of miles away, to me that's still mind-blowing. I mean, I grew up in New York City, I could really see the stars, you know, and now here I am, you know, watching children be connected, you know, to outer space in a very direct way. So that's incredibly exciting.